So just a request to students, we are often getting emails about different queries and all that. So if you see, there are many channels in these Teams for the Koala. So there is one channel dedicated to student discussion. So regarding any assignment, if you have any issue, any student can write the issue in this, and we faculty members and teaching assistants and the lab assistants, one of us will just directly write back here in this channel. I think then the query gets resolved and it is known to everybody. So I mean, it's better that you don't send mail unless it's some other issue. But any query regarding assignment or something, you can just write here. Okay. Okay. Pradeep, you may start.
Okay, sir. Thank you. Today I will show you how to install your IC 14.7 and also how to use IC 14.7 for writing your regular code and how to simulate. Okay. So first of all, I will show you how to install IC 14.7 because you may face some problem while installing IC 14.7. So already Sir has provided you the link. So this was the link from where you can download the IC 14.7. Okay, hope all of you have already downloaded the IC 14.7. So now I will show you how to install the IC 14.7. So you have to click X setup. So now installation will start. So this is the welcome page of IC 14.7 installer.
Sir, can you please also show like which one to download? Like there were many options like while I was downloading.
You have to download the IC 14.7, the latest version.
No, yeah,
Okay.
like in the same version, there were many like for Windows 10, and then in Windows 10 also there were many options to download, like which one to download.
Okay. The version which I have downloaded, just I am showing you. So this is a version IC 14.7 for Windows 10, 14.7. This one VM underscore 0213 underscore 1. So this is a version which I have downloaded.
No, like okay, I'll see it. Okay, I'll
See,
check it.
if you click that, just I'm showing. So if you click this one, so this one, this 14.7 Windows 10. Okay, so this one you have to download. If you click this one, your download will start. Is it clear?
Yes, it is clear now. Yeah.
Okay.
Sir, in my laptop, sir, if I click on on the XE setup, it tells that your virtualization is not enabled.
Your virtualization is not enabled.
Yeah, but I checked.
Same issue.
Yeah, I cannot even start the setup.
What is
See
what
that
is what is your system?
Windows 10, i7.
if it is Windows 10, I don't think there will be a problem.
Yes, there is a problem.
There is a problem.
Okay, I can do one thing then. I can send you the another version of this 14.7. Okay, so that can be installed in Windows 7 as well as in Windows 10.
Okay, that.
Okay, so that I will upload.
Okay.
So if you click this one, this X setup. So you have to now you click next. So after pressing next, now you have to accept the license agreement. So you tick this one, I accept both. Then click next. This also you have to accept. Then you have to click next. Then from here you have to select the product. So you select this product, IC Design Suite System Edition. because this system edition, it includes all these three edition: logic edition, EDK, as well as for the DSP. Okay, so you click this one. Now you click next. Now from here, you uncheck these two: acquire, manage a license key, and this web talk. Okay, license key later on you can provide. So at present, this is not required. So now you click next. So here you have to provide the directory. By default, it will be C drive, is where you have to install the this software, IC software. Now, if you press here next, your installation will start. Okay, so there is no problem. But while going on installation, sometimes it will ask you for installing this WinP cap as well as cable driver. That time you have to press the OK. So if you just press OK, so your installation will be completed. So there will be no problem. Even though if you face any problem, you just send me the screenshot of that error. Okay, so then I will tell you what to do. So this way you have to install the IC 14.7. So now I will show you how to use IC 14.7 for writing the Verilog code. So this is my IC 14.7. So first of all, you have to create a project. Okay, so you click this one, new project. So here you have to give the project name. So I will take one simple example for Mux 2:1. Okay, and here you have to provide the location directory, means where you want to keep your your project. So you just select your directory. This will be SDL. Now you click next. So from here, now you have to select which family you're using and which device you're using. Okay, so in our lab, basically we are using Hexas 4 board. Okay, so that is Artex 7 FPGA trainer board. So this board actually we are available in our lab. So here you can see the FPGA is XC7A 100T 1CS G324C. Okay, so this is the FPGA family which we are using in our lab. So this you have to specify in your project here. So for the product category, you select all. For the family, you have to select Artex 7. Okay. Now for the device, you can see in the drop-down menu, there are two devices available, XC7 100T and XC7 200T. But the device which we are using in our lab, that is basically, you can see here, that is XC7 100T. So you have to select that one. Okay, so this one, XC7 100T. And the package is CSG324. You can see from here, the package was CSG324C. So this you have to select. Now speed. So here speed you have to select. Here you can see there is a 1C. So this one, this -1 indicate is a speed. Okay, so this you have to select. Here you have to select -1. And for the synthesis tool, you have to select XST Verilog. And for simulator, here we are using iSimulator. Okay, so you have to select iSimulator, iSim. And preferred language, there is a Verilog, because we are writing code in Verilog. So now you click next. So this is very important, the selection of your family and device, because if you select different family, different devices, then actually that code will not work on that board. Okay, so this selection is very important. So now you click next. So this is already summary is given here. Now click you finish. Okay, so now you can see the left hand side. This is the project name which I have given, and this is the device which I have selected, the device. Now you have to write the code, Verilog code. So for that, you just right click here. Now you can see here there are some options are there, new source, add source. Okay, so suppose you have written already your Verilog code in Notepad or Wattpad, so that file can be also added here directly. So that time, for that time you have to click the add source. And now if you want to write the code now, so you have to click the new source. So click new source, and from here you have to select Verilog module. You have to select Verilog module for writing your Verilog code. So now here you have to give your file name. Okay, this is the file name, and this is a location where you have to keep the project. So and now you click this one, add to project. Means whatever file you will write is whatever file you will add, that will be added directly to your project. So you have to click this one, add to project. Now you click next. Okay, now here this is where you can define your module. Now I'm going to show you this example. Already Sarah has discussed in the class. So here you can see there are 3 input A, B cell and 1 output F. So this you can define here directly. Means here you have to write A. So this is my input. If you write F, then this you can define as my output. Okay, so this way you can define here. Okay, but generally we don't do this one. We directly write the code directly in the edited page. Okay, so we will see that one. So that is more convenient. So now you press next. Click finish. Yes, now you can see this editor page is available here. Okay, with my file name, with the project name. So now here you have to write your Verilog code. Okay. So I have written one code. Just I will copy and paste there. This is the same code which Sarah has discussed in the class. You can see module marks FAB cell output, same code. This one output F input where I have defined this F1, F1, F2 and this N cell. Okay. So now after writing the code, you have to synthesize it. So if you just expand this synthesize, you can see if you click this synthesize, so first it will check the syntax. Okay, so I'm just double clicking this one. So it will synthesize. First it will check the syntax. You can see here in this console part, you can see synthesize xt, running xt. Okay, so reading design. So all okay. So synthesize is completed. So if there is any error, you will find this error here. If you click this error, so if there was any error, you will find the error will be given here with the line numbers. Okay. Now suppose just I can show you. I'm making one error intentionally here. Suppose I have written here and 1. And now if you synthesize this one, so you can see there is an error. Line number 26, line number 26, so instantiating, there is some error. Okay, so you can find the error here. So once the synthesis is complete, so we can, yes, now it is completed. Okay, successfully it is completed. So you can see the RTL schematic. Okay, so if you just click this one, view RTL schematic, you can see, start with the schematic of the from the top level block. You click this one, press OK. So this you can see, this is the marks which already have. Okay, this marks. Now if you double click inside this box, so this is the complete schematic diagram. You can see RTL schematic diagram. So whatever you have defined like this is 2 AND gate, 1 OR gate, and 1 NOT gate. So you can see this one. So this was a NOT. Okay, these 2 AND gate and this is the OR gate. And also you can also view the technology schematic. Means technology schematic means what? That is the inside. If you click this one, you can see this one. This how actually in the FPGA how it is connected. Means how many IO buff, means input buffer and output buffer, and how many LET has been used. Okay, so this is the schematic that also you can check this way. Now the important thing is the summary. This is this design summary synthesized, because when you are doing synthesization, that means actually you need lots of information. Okay, how much was the delay? So all these things report you can find here. Means how many LUT is used. You can see here in this synthesis report. This was reverse utilization summary. Here you can see there are 63400 LUT is available in this FPGA, but only one has been used in your project. So all those information is given. How many buffer are used? IO buffer, 4 IO buffer. Okay, available how many? 210 IO buffer are available. So out of this, you have used only 4 in your project. Okay, so already we have seen the technology schematic. From the technology schematic, you can check this 1, 2, this is 3 output buffer and 3 input buffer for cell. One is for A and one is for B. Okay, and only one LUT is used. So all this information you can get from this synthesis summary. So 1 LUT and 4 IO buffer, means 3 input buffer and 1 output buffer is being used. Now if you click this synthesis report, the details of your synthesis is given here in an elaborated way. Okay, this is synthesis option summary. This is your target option, general option, means all the informations you can get here, even the timing also. Okay, so I will show you. This was your design summary. LUT has been only used 1, IO buffer 4, one input buffer is being used and one output buffer is used. Okay. The details you will find here. This is a timing report. So no clock signal is been used. So it has already shown. And how much time it has taken, that all information is also given here, the total delay. Okay, so here you can find out the total delay was 1.240 nanosecond. Okay, so for the input buffer, the delay was 0.001. For the LUT, it was 0.124 nanosecond. And for output buffer, there was 0. So total delay was 1.24 nanosecond. Okay. So this information you can get it from here. So once you have completed the synthesize, now you have to do the simulation part. Means you have to check the waveform of your this module. So for that, what you have to do? You click here, simulation. Click this one, and now here you have to click right click, new source. Now for writing the test bench, you have to click Verilog test fixture. Okay. When you are writing the module, that time you have selected Verilog module. For writing the test bench, you have to click Verilog test fixture. So now you give the file name. So this is my test bench. Click add to project. Click next. Next. Finish. So this is the editor page. Okay. So here you have to write your test bench for testing your module, your project. Okay, so this is a test bench. So here I have, this is my input, this is output, this is your UT instantiate. I will instantiate here. So already Sir has discussed in the class. For instantiation, you can use two methods, either by function means by name, or you can by calling in a proper way, means input output that way. So this way, first I initialize A B cell to 00, and I have used this $monitor just to check the waveform for A B cell, and this input I have given after every one delay. Okay, so you have to click this one, and here you can see this is iSIM simulator, which already we have selected. So click simulate behavioral model. So if you click this one, first it will check the syntax if there is any error. If there is any error, again you can check in the error option. Okay. So here you can see this is my waveform output. Okay, and the output in the reveal form also you can just I have shown here. Okay, select I have kept 0 by changing the AB. You can see here When the select is 0, whatever you have given the input in A, that is coming in the output F. For A is 0, so here F is also 0. Okay. And when I have select is 1, you can see the B is coming here in the output 0 0 1 1 1 1. From the waveform also you can check. If you click here, you can see the values. My A, B cell is 0, output is also 0. For next, you can see that I have given my cell is 0. So A is 0, so that's why F is 0. So this way you can check your waveform output. So this way you have to check your project. So if you have any doubt, you can ask.
So in the synthesis report that you showed, the timing delay, that is the delay we have to consider, right? For comparisons between modules.
Yes, yes. So that is the actual delay. That means that complete delay is given there. Means whenever you're applying the input, from that time to the time which you are getting the output, that complete delay is given there. Means I have shown you that diagram that just I'm showing you.
So if you have a more complicated circuit, right, then you will, and with say, like several combinatorial components and several sequential components like flip-flops, then you will find that this report gives you the flop-to-flop delay. Okay, so it will show you various paths and it will also show you the critical path, which means the worst case delay, because the critical path will decide the maximum clock frequency that you can drive your circuit with.
So in the report, you can get the delay from here to here, means from A input to this output. Okay, from B to this, from here cell to, say the maximum delay will be where? Your maximum delay will be, actually your maximum delay will be here, means from cell to this NOT gate, then this AND gate and this OR gate. Okay. So this will be your maximum delay.
So the value displayed there is the maximum delay, right?
Yeah, yes, the
You can
part
see
by part,
report, right? So
part by part delay is given there. That report which I have shown you, that report, the part by part delay is all also given. Design summary. Summary report. If you click this synthesis report, here you can see the delays are given. See, this is the delay for the input buffer, means from I to O, means in to out. For LUT is also given. For output buffer, it's also given. And And overall total, this delay is actually from your input buffer to the output. This is the delay for the 1.24 nanosecond. That is the total delay. And for only input buffer delay, that is 0.01. And for LUT delay, that is 0.124. So
Yeah, so this total net is called as a path. Okay.
yes.
You see at the top it is written total number of paths.
Yes.
So
yes.
in this is a very small circuit, so it is showing you like few paths, maybe one path. But if you have a more complicated design, then you will have multiple paths, and all those critical paths will be displayed in the report.
Yes.
So sir, this total delay that is shown here is the delay of the longest path. Am I right?
This is the longest path, and the path is also elaborated here. You can see that time of
Yes.
LUT.
Yes. Understood.
Sir, there is some request to extend the deadline. Do you really want an extension of the deadline till Sunday? Or
Yes, sir.
I mean, we won't extend it till next week. We can extend it till say Sunday or so.
Yeah.
Because from first week of September you will be starting with assembly language programming. Okay. Whatever is being covered in theory class now, you will need to start assignments on that. So
we'll again come back to Verilog. Okay, so
we will again come back to Verilog.
Yeah,
but
so
in
the plan is
September
that,
you will primarily work on MIPS.
Yeah, so we start with, so we have started with some initial sort of, you can say, drill exercise on Verilog. After this, we will go into assembly coding using MIPS, and following that, we will be essentially going to a more elaborate usage of Verilog coding, where you will be designing a RISC processor, and then you will see that the same thing that you have been seeing, the mnemonics in the assembly code, the way you execute them on a standard processor, okay, or maybe a processor simulator. So we will try to see that whether you can essentially execute similar kind of instructions on an actual hardware processor that you will be building. Okay, so that is the main objective. So the initial parts are therefore extremely crucial so that you get an overall grasp of the topic, and then we will finally launch into developing an end-to-end simplified RISC processor using Verilog. So one small point that I would like to add to what Pradeep presented is that he showed you one multiplexer design, right? So, but in your real life design, like even in the adder circuit which you are implementing now, you see that there are multiple blocks, right? There is a half adder, full adder, and all these things, right? And maybe the carried lookup adder. So usually, right, you will basically instantiating them separately. Like you will write a file for half adder.v, like ha.v, so it will have a module half adder. Then you will write a file fa.v, module full adder, and then maybe a module CLA or a module carry lookup adder. And once you put all these files in the same folder in your machine, right, the tool will automatically detect the hierarchy. Okay, like if you instantiate the carry lookup, like the full adder in the carry lookup code, if you are instantiating the half adder in the full adder code, then the tool will automatically detect the instances, and you will find that it will give you a top level access like a CLA maybe module. So once you click that, then you will be able to see inside that the sub modules will be displayed. Okay, so don't write one single monolithic big Verilog code with all the modules written over there, but try to write them in multiple files. So this modular approach of designing Verilog code is very helpful, or any code for that matter, to do debug and later on, like for instance, like if for example tomorrow are not happy with the performance of a specific component, right, then you can just replace it by another code for another design. Okay. So any questions?
Sir, I have an assignment specific question. For the problem 2, we were asked to compare with a CLA 16-bit using a lookahead carry unit and another CLA 16-bit with rippling carry. Right. So do we have to submit all these modules, or do we just have to submit a CLA 16-bit and then in the comments we have to write, like, how many files exactly do we have to submit?
Okay, so the question does not tell you that, like, what eventually you have to submit.
No, it was just asked to compare, but they.
Okay.
So that is just like we do it and compare, right? But if we are submitting everything, then there'll be a lot of files and test benches. So
No, I think the final, yeah. So there is one question which asks you to compare with a 16-bit Ripple carry adder, okay, or an RCA, okay. But yeah, so what you have to, yeah. So you are being told to upload a single zip file, right? So in a zip file you can. So there's a question which talks about design the lookat, carry unit, and integrate as shown in figure 1. That is your part 2 of the question. And then the comparison part is more of like an sort of descriptive. Anyway, you have to do the design, but in the design you have to write down the comparisons. But what you have to upload is the design of the carry lookat data in this part of the code of the question.
Sir, so we don't have to submit our observations.
No, you have to submit your observations also, but that is in a text. So you can write in a doc file or maybe a PDF file, and that you can keep in your zip folder. So the zip folder will consist of, like your Verilog codes and a document which basically will answer these questions one by one, which has been asked.
Okay, sir.
So the circuit designs that we'll put inside the document which we'll submit, those circuit diagrams have to be drawn by hand or like. I'm
See,
sorry,
whatever
sir.
you do, right, your evaluator should be able to understand. Okay, so ideally, I mean, if it is not too much of a pain, you can draw by using some kind of draw instruments in your word processor. It's not very difficult. Okay, but if you really want to draw by hand, maybe you can do that, but that should be legible. Okay, if it is not legible, then you will be penalized.
sir, and one more question. In the zip file, can we have a file hierarchy or do they all have to be in the same place? Like file hierarchy would be better to, have them cleanly organized.
So in the zip folder, if you are uploading Verilog codes, right, then suppose there is a folder for CLA. So in that CLA folder, you just put the multiple modules Verilog codes that you have. Okay, and the hierarchy should be like the hierarchy should be in your instances. You do not like yeah. So if, for example, like if you have a full error code like a fa.v file, you can in the same folder you can keep a half ha.v file also for half adder. Okay, so but what I would insist is that don't make one single file, make separate files actually. Okay.
Okay, sir. Thank you.
Sir, actually, what I meant by hand-drawn versus otherwise was hand-drawn being a drawing with some software by using some software on doc or something like that, and the other option being, for example, for the 16-bit CLA, there is already a diagram given to us in the PDF. So maybe, so like, can we just copy and paste that diagram itself, for example?
Don't do that. Then I will get the marks, right? So do it yourself.
All right, sir. Thank you.
Any more questions?
Like finalize the date and time for.
Okay, so Adesi, what is your suggestion? The deadline.
Yeah, what do they want?
Deadline, like the final deadline. So do we give them till Sunday or next Wednesday?
I think
Next Tuesday.
I think let us take the call on Friday. Currently, the deadline So what we can do, my suggestion is initially to extend it to Friday midnight. So like Saturday 00 hours. And then towards the end of the class on Friday, we take a call by asking the students what is the status. If they say we won't be able to finish within this weekend, then we will extend it till 2 p.m. of next Wednesday. Otherwise, we will keep it till Sunday or something. I mean, I think right now let us keep it till Sunday. I mean, we can keep it.
Yeah,
till
Sunday I think is okay. Let's keep it till Sunday actually. Okay, so without
Sunday,
any
yeah.
hassle.
There is enough, I
Let us
think.
keep it till Sunday.
Yeah.
And
Sunday-
Friday we will take a call. And another thing is individually, many of you are emailing that our exposure to Verilog is less, so we are facing difficulty. Of course, your exposure to Verilog is less. That is understandable. Say, for example, with the C programming language, you have been exposed to, many of you from school, and all of you from first year, you have been using it extensively ever since. Of course, you haven't done so many assignments with Verilog. That is understandable. But don't get impatient. So those of you who learned C programming language in first year, did you get desperate when you obtained, say, a compilation error or a seg fault? It will happen. These people learn through doing it. Okay. Verilog is as complicated or probably even more complicated language than C. So it will take some time to learn. It has some peculiarities like an inherent inbuilt concurrency about the different units operating together. Things are not sequential. It represents hardware operations. All these things are new to you. Of course, it will take time, but don't get impatient. Okay, you will learn through trying it out. And now you have got the tutorial on the software also. Try it. What might happen? You get in compilation error, you might get an synthesis error. Okay, so then you debug and that's how you learn. Don't get like some of the emails that you are sending. I mean, it's like almost a SOS call. Sir, we cannot do anything. We don't know Verilog. I mean, that is okay. I mean, nobody expects you know everything of Verilog, but you will learn. Okay, Verilog is it has become a very large language. We haven't covered many features of the language of like what the new version of Verilog called System Verilog from 2012 or so. That has become a very complicated language. But we are just considering a subset of that, what is sufficient for your assignments. And be a little patient and solve the assignments into, you have 2% teams. And there is a lot of resource available on internet. Okay, I mean, any bug you face or any question you have that how to write this thing, how to express this in Verilog, if you do not find it in the slides or in your books, you will find it online. Somebody has discussed it in the forums, or there are tutorials on Verilog also where these have been discussed. Okay. So you have to give it some time. The problem is now you are in third year, so you think any programming language will come very easy to you. I mean, you can learn it in 5 minutes or so. That will not happen with Verilog. Verilog is not any other programming language. Okay, it is slightly different. So you have to be patient. You have to put it, and that's how you learn. But think about the part once you learn it, you would be able to implement your own processor. Of course, it won't be an Intel i5 or i7 processor, but it will be a full-fledged processor towards the end of the course, which you will implement an FPGA. And if you are persuasive enough and if you are hardworking enough, you would be able to write assembly language code targeting that processor, and you can run implemented on that type of processor on FPGA. So just imagine the power you will have. You will implement your own processor on which in that custom assembly language you will write algorithms. And those you can execute and get the results. That's not non-trivial thing, right? It's a highly non-trivial thing. I mean, if you think about it, it's almost unbelievable that a UG students can do it. So try to take advantage of this technology, learn this technology well, and with time, it will require time. You have 1 semester, don't get impatient, okay? You have 1 semester, learn it slowly. And with more assignments that will happen again after we finish with assembly language programming, you will get more exposure, and I mean after some time you will get used to the peculiarities of the language.
Excuse
So
me, sir.
there is one question. So in the assignments, many questions were asked and observations to be made. You include the info as comments in the Verilog code. No, you have a report. I think a report will be better. Include the report in the zipped folder that you will submit. Okay, a text or a PDF file. I would suggest a PDF file. That will be good, because that when the TA grades your assignment, by reading the report, the TA can understand how much effort you have put in. Okay, how much understanding you have developed by going through the assignment. See, everything this is a program. Any programming language you cannot learn by reading textbook. Programming language you have to code.
No, so one thing I would like to mention is that the comments that you write on Verilog code are so that people can understand what you are doing.
Yes,
Right? That is
of
the
course.
usual
Comment.
commenting. But
Yeah,
the answer,
liberally comment your code so that people can understand.
yes, so you have to do indentation as you usually do in any programming language. Okay, but the answers to the specific questions that has been asked, so that you are also supposed to furnish as a report. So that's a separate part that will be evaluated also as well. Okay.
Yes.
Sir, I had one more question. So on Moodle, the submission is set to be Friday, Thursday midnight. Not was it intended to be Thursday midnight or Friday midnight?
Okay, that will update.
We will set it to Sunday
Right?
Sunday midnight. That we update.
Sunday midnight we will update that. Okay.
Don't worry.
Okay.
So like, sir, instead of like 12.
What?
Yes, sir. Instead of 12, could you please put it as 11:55 so we know which day it is exactly? Because
Okay.
when it's exactly 12 a.m., we don't understand which date.
Yes.
Right, we'll do that. Okay.
I am doing it right away. Don't worry.
Sir, and are we so in the example that that we were shown in the demo, the mux was made using structural coding, the structural way of coding in Verilog, but we can use continuous assignments and such things, right?
Yes. Whatever is convenient, you use.
I did not get the question. Can you repeat once more, please?
Sir, we can use continuous assignments in Verilog, right? When we are writing our code, we don't have to design it structurally, like using and gates and OR gates and NOT gates and stuff like that.
So ideally, the top level of your code should be structural. As you go down to the leaf level, you can use behavioral constructs. Okay.
All right.
So the top level, try to keep like draw a picture, circuit diagram, and make it structural. That will be very convenient. Okay.
Okay, sir.
Any more questions, comments? Okay. So if not, I see what do we do.
Yeah, I think let them work on it. And
okay.
Okay, there is another question. The delay is what we get on Nexus 4 board or any general hardware simulator. So has this question been answered, Aryan? You asked this question. Are you there?
Yes, sir. I'm still in doubt.
Okay, so you did not get the answer to your question. Okay. So this is for a particular FPGA that is on the Nexus 4 board. delay is not for a board, delay is for a FPGA chip. The circuit that you have mapped on the FPGA chip, that circuit is called RTX, that FPGA is called RTX 7. That FPGA chip is manufactured, putting it on a PCB and adding additional chips to it and peripherals to it. A company called Digilent comes up with this Nexus 4 board. There is no concept called board delay. Okay, so this term board delay for the board is wrong. The delay is for that FPGA and in particular for the circuit that you have mapped for the FPGA. If you change the FPGA, Xilinx produces many other types of FPGAs also. Okay. RTX is kind of, I think it's kind of an old FPGA model. It is still popular, but it's not cutting edge. There are many other FPGAs also on that. If you perform the same design, your delay might be much lesser. Okay, because as advanced technology advances, the delay gets smaller. Does that answer your question?
Yes, sir.
Okay. No, Friday also there will be a class, so we'll be there on Friday. We have extended the deadline, but please try to finish it within Friday. The reason is, see, this is not an assignment that should take that much of time, because when you attempt your lab exams, etc., if your coding speed is extremely slow, that also is a concern. I mean, you be patient and you develop your code slowly, try to debug, that is fine, but
see, if your submission is not complete on Friday during the lab, you must be working on that. We can at least check that.
Concept
should be online and working on it.
Sir, it's actually not about the code. It's about getting the hang of the software, because we are completely new to it.
So that is why I'm saying use that student discussion channel.
So right in Friday, we will decide later.
So whatever be it, right, there is a new software, so there will be a learning curve, right, and you have to try your and like put in your best effort to learn that. So whichever be the deadline, right, and you are already habituated and you will be working with deadlines, right, so take this deadline and you try to work on basically, and if you face any problems, then let us know, but put in your best effort. That's the most important. And this is not like a very rocket science.
Yeah, we can
that cannot be
keep on extending deadlines like forever.
So try to get a like, I mean, you have already seen this video, right? That will be shared. Basically, it's a tutorial on the tool. So this is a software which largely works on Windows, and most of the time we have seen it is very stable on Windows. Okay, so those who are using Windows, I do not anticipate any problem whatsoever. Okay, so if you are facing problems, then that's very strange actually. Okay. So, but anyway, I mean, maybe there will be a few hiccups, but I mean, try to get the software installed maybe by today, actually. Okay. And once you get it installed, then you're ready to go for your practice and other things, right? Okay.
So, just asking, like some of you had issues with systems. You have mailed hardware lab, and they have arranged for systems. Is anybody still there who has such issues, which has not been resolved? Please pick up now. Then.
Acha, Aditi Mishra, 19CS10015. Have you joined Moodle, the lab course? Aditi, are you there? Aditi Mishra, are you there? So anybody know, students, anybody aware the whereabouts of Aditi Mishra, because she is not joining the Moodle course. She's not in today's class also, it seems.
He is in ERP, right, Rajat? I mean, in the course list, but not in.
Yes. I think she's in ERP. Yes. Because I got her email ID from ERP, and she has received the email. Must be. Students, anybody, are you aware?
Who is the facad of your batch?
Pavitra Mitra, sir.
Hello?
Mr.
Pavitra Mitra.
Pavitra Mitra. Okay.
Professor Pavitra Mitra is a facad of the BTech batch or the dual degree batch? BTech
batch.
BTech
batch, sir.
Okay. And who is the dual facad?
Batch.
Swagata Sanyal,
We'll
sir.
need to speak with him then.
Yeah.
Maybe I don't know. She's taken or her name.
Yeah, let's do that.
Yeah, so so next day when you come to the lab, what we expect is that all of you should have access to the Xilinx ISE which is working on your systems. Okay, this is at least you can take it as a mandatory requirement. Okay, so if you, I mean, next day we will be taking, or like make a random call to ask you, and also ask you to share your desktop to show that your system is working and you have essentially access to the software. Okay, so please try to ensure that this is working before you meet. And if there is, like a certain things that you are trying your best and still not able to get it working, you can inform us. Okay, that is fine. But there should be kind of, like an urgency from your side also to get the system working. Okay. Any questions? How many of you are able to get the Xilinx ISE working, by the way? Like like at least, are there any couple of affirmative endpoints? Yeah, I see few hands on, which is good. So what I would also request is that those who have been able to get it working, right, to kindly help their friends and colleagues, because that actually helps to disseminate the knowledge much faster. Okay, so try to maybe like form an internal group and share, like if there are some like problems that some certain people are facing, and if that is still there, then of course definitely you can most welcome to like ping us. But yeah, so remotely is also fine, that's not a problem. But whatever, right, each of you should have an access. Okay, so you can show a remote access, maybe connect somewhere and show us that you are able to get the ISE working. Okay. Okay, thank you.
There is a question, Deep Mojumdar or somebody, you are raising your hand. Do you have any question? Somebody is raising hand. Yeah, what is your question, Deep?
Oh, sir, I don't have a question.
He's probably saying that he's able to get the ISE working, right?
Okay, fine.
Yes, sir.
Okay, good. Okay, so try your best, and I think we can meet next week, right? If we are done more or less. Okay. I see anything more? Okay. or should they continue?
Yeah, I mean, we will it or so I have right now set the deadline.
The deadline right now is what, Friday or Sunday?
Friday, till Sunday night, I can do it.
Okay.
I think it's like Thursday midnight or so. I've extended till Friday 5 p.m.
Okay.
Should I extend it further till Sunday or so, or let it be till Friday,
Okay, so,
and on Friday we take a call?
Okay, we take a call on Friday. No issues. Yeah. But the point is, what we want
Yeah,
largely
we'll
from the
take a call on
students
Friday.
yeah, so is a sincere effort. Okay, so try to get to as much as working as possible, and then we will also try to cooperate with you as much as we can. But please understand, this is
just
these are laboratories, so we will have deadlines. Okay, and because otherwise we cannot cover ground. Okay, so therefore, right, you have to put in your best effort.
Last year also classes were conducted online, right? Last year also we had classes online using exactly same infrastructure, and there were minor hitches, but only in the first week. Within 1 week, everything was smooth.
Right. So at the end of the day, you are using a software, right? So should be working perfectly. And also keep in mind that this is like there are 2 contact hours, so which means that there is a good amount of like work expected. So and accordingly, right? I mean, you also should put in your effort. If you do it, I can guarantee you, or we can guarantee you that at the end of the day, you will have something like enjoyable, where you can see certain thing which you have made yourself and which is working. But you also have to cooperate, otherwise you will not be able to reach the end point in time. Okay.